Today we're making an American cream ale. The recipe as well as the ingredients were provided by Brewer's Best. The ingredients consist of liquid malt extract, corn sugar, dry malt extract, Willamette hops, Saaz hops, and Safe Ale US 05 dry ale yeast. The species of yeast is Saccharomyces cerevisiae. We begin the brewing process by bringing 2.5 gallons of water to a boil. The next step is to wash the ingredient containers and vessels with a surfactant, like this dish soap, in order to remove unseen particulates. We will now want to sanitize the containers and vessels with some sort of sanitizer, like Star San. If we zoom into the container, we could see the two active ingredients are dodecyl benzene sulfonic acid and phosphoric acid. Dodecyl benzene sulfonic acid, like all surfactants, cause water to have a lower surface tension, allowing the solution to get into the nooks and crannies on the vessels and containers. Phosphoric acid is a weak triprotic acid with a pKa of 2.1, 7.2, and 12.3. Phosphoric acid will only partially dissociate at low pH, losing a single proton. In its partially dissociated form, it will gain entry to the cell, where it will once again shed a proton. Now that the water is boiling, it's time to add the malt extract. Although the risk of botulinum toxin being located in the can is low, boiling at 100 degrees for 60 minutes is sure to denature it. Unfortunately, this 60-minute boil won't kill Clostridium botulinum endospores, so other control methods will be needed. These methods will be explained near the end of the video. You might be wondering why we have to add so much sugar into this mixture. That's because Saccharomyces cerevisiae is a facultative anaerobe which, in the absence of air, converts sugar to ethanol and CO2. Ethanol is the psychoactive drug within beer that leads to its intoxicating effects. It also imparts a warming sensation in the back of your throat. CO2 is the compound that causes the bubbles in the beer. The degree of carbonation will determine how light the beer is perceived to be. Any unfermented sugars will lead to some viscosity within the beer, a great counterbalance to the crispness of the CO2. In this recipe, we're adding hops at two distinct stages. The first being the addition of the Willamette hops at the beginning of the boil. A 60-minute boil of the Willamette hops will lead to a more efficient extraction of the alpha acids within the hops. This will impart some bitter flavor to the beer, but due to the 60-minute boil, most of the volatiles located within the hops will be boiled off. The second addition, a 20-minute boil of the Saaz hops, will also extract alpha acids, but due to its shorter boiling time, it'll leave some volatiles within the beer, leading to the beer being more aromatic. A density reading of the beer will then be taken with this hydrometer. Initial and final density readings of the solution will allow us to know how much sugar the yeast consumed and therefore roughly how much ethanol was produced. Now it's time to add the starter culture. As stated before, the yeast being added is Saccharomyces cerevisiae, which has several common names such as brewer's yeast, ale yeast, and baker's yeast. In the wild, Saccharomyces cerevisiae can be found on matured grapes as well as on the bark of oak trees. Something special about Saccharomyces cerevisiae is its ability to hydrolyze maltose by use of the enzyme maltase. This reaction creates two glucose molecules, which can be used by the yeast for fermentation. A lid will be added as well as an airlock in order to keep oxygen out. The purpose of the airlock is to allow CO2 as well as unwanted volatiles like diacetyl out. Without the addition of this airlock, the lid on the container can easily explode, leading to the possible contamination of the beer. It is necessary to take pH readings often. Not only will pH readings allow us to understand how well the fermentation is going, it will also keep us informed on whether or not the pH is dipped below 4.6 within 48 hours. Having a pH below 4.6 within 48 hours is necessary in order to keep Clostridium botulinum at bay.